want to start off by telling you that one of the reasons I love Angular is because it's so easy to use reactive programming concepts inside of my components. But I also want to improve that experience for developers, because many of you, like me, have run into some problems when we try to do this in our components. For example, let's say we've got this template here, and I'm using an observable directly in my template with the async pipe. Everything looks great until I jump to the definition of this component, and I realize that the observable they're using is actually one coming from the HTTP client. Okay, but here's the problem. When I look at that template again, since I'm subscribing to it twice, the request fires off twice. Bit of a gotcha. So I point this out, and we go refactor the code, and we sort of think of a new way to bring this into our template. And you start to see syntax like this, where now I'm just going to use ngIf. I'm not actually using it to control an element, but I'm using it to actually unpack that value out of the observable and use it as a template variable. This makes it a little bit easier to use, and I no longer have multiple subscriptions running. But it gets a little messy if I actually want to use more than one observable. You start to nest it, and it gets a little chaotic. So that's not a great approach either. Another strategy we could take is we could go back to the component definition, and what we could do is, instead of using the observable directly in the template, we could subscribe to that observable and take that value and actually store it as a property on the component instance. But you may have already noticed there's a bit of a bug here. By not cleaning up that subscription, I've actually got a bit of a memory leak. So I need to go back in, refactor the code, capture the subscription as well, and make sure that I'm unsubscribing from it in the onDestroy lifecycle hook. So once I finally got it all working in terms of making it easy to use this value in my template, I go to actually run the application, and then something crashes, and I end up with stack traces like this that are just ridiculously long, mostly because, well, Zone.js is interplaying in a weird way with RxJS, making it hard to debug what's going wrong. So I kind of want to know, could we provide a better experience for reactive programmers who are trying to author Angular components? And I want to challenge you to help me build this. So let's take a look at how we can maybe solve this as if we were all open source authors trying to launch a new library. But first, my name is Mike Ryan. You can follow me on Twitter, GitHub, and Medium at MikeRyanDev. I'm a software architect at an IoT company called Synapse, based in the United States. I'm a Google developer expert in Angular and web technologies, and I'm also one of the co-creators of the NgRx project, a collection of open source libraries trying to bring reactivity to the Angular framework. So my goals for improving reactivity in Angular are this. I want to make it so that developers can use observable values easily in their template. But I also don't want them to have any accidental memory leaks. I don't want developers to have to think about managing subscriptions. And I kind of want to give developers the opportunity to build Angular applications without Zone.js to maybe improve debugability or performance. Now, when I start to build an open source library, I'm a big top-down designer. I like to think about, well, what would my users want to use? What would be a good experience for them? So to sort of share some of my ideas about this API, I have to talk briefly about how change detection works. When you've got a tree of Angular components that comprise your application and something interesting happens in them, one of those components might become something called dirty. It means it needs to be updated to the view. Angular is then going to go through this tree of components from the top down, and it's going to find any components that are dirty and actually update those views for us. So where do zones come into play with this? Well, interestingly, zones don't actually have much to do with the change detection mechanism itself. Zones just tell Angular when to actually run change detection. Zones are going to patch all the asynchronous APIs in the browser, and when your code interacts with one of those APIs, that will cause change detection to be triggered. But this has a potential trade-off. First, it could potentially run change detection too often. If you're using a particularly noisy asynchronous API, like a WebSocket connection, you might incur a penalty because zones don't know that not every asynchronous operation needs to cause change detection to run. They also have the potential trade-off where it might cause change detection to be skipped. So if you're using a particularly obscure browser API that zones haven't actually patched, then you might be caught in a situation where your UI is not updating. So, open source designers, how can we go about trying to fix this? Well, I want to challenge you to really think and look around other ecosystems. As Angular developers, it can be really easy to sort of look within our own ecosystem and try to figure out how to solve this within those walls. But I like to really look into how other frameworks and technologies are trying to achieve some of these problems. So I'm going to do something kind of taboo. I'm going to put some React code on the screen and walk through a little bit of React for a second, because it actually solves this in a pretty interesting way. In React, you have this idea of component-level state, the values that change. And when that state changes, the view gets updated. And as the author of a React component, you tell React exactly when that data updates. And what's really interesting about this is that is how React knows when to run its own change detection, because the developer has told it that the underlying data has been updated. So there's some pretty interesting benefits to this approach. First, changes to state are what causes change detection to run, not asynchronous operations. This means that the developer has full control over when change detection actually runs, because they have control over state changes. This can make it a little easier to keep the UI consistent and up to date in a performance way, or a performance-sensitive way. So that's a pretty interesting approach, but if we were to try to do this in Angular, it would have to overcome the problem that Angular doesn't have component-level state. We don't have a built-in low-level state mechanism for our Angular components. But actually, maybe we do. If you're using something as simple and elegant as a subject with a service, or maybe something more complex like NgRx, then as an Angular developer, you know that you're actually tracking state with observables. Observables are the mechanism by which we track changes to our data. So if I want to try and design a way to do this better at the component level, I kind of want to borrow from both. So let's imagine instead that we had some kind of like hook in Angular to handle our change detection in our components for us. Whereas component authors, we'd say this is the kind of state this component has, and then we can call into some kind of connect hook where we pass in a dictionary of observables that will subscribe to those observables and actually update our components for us. Then from there, we could take that state and use it inside of our templates without having to worry about the async pipe or multiple subscriptions. So how can we go about actually building this? Well, first, we're going to need a demo app. As an open source library developer like yourself, you're going to need something to actually tinker with and play around with. And I want this demo app to actually use Ivy, because there's a few interesting things that Ivy is going to give us when we actually go to try and build this. First, Ivy is going to enable us to build something called higher order components. We'll get into those in a minute, but the idea is that we'll be able to inject custom behavior into our Angular components. Ivy also has new change detection APIs that will make it just a little bit easier to work without Zone.js. And since we're talking about binding state into our template, it's going to be really great that Ivy is going to give us improved type safety in our template. So let me show you the example app that I have built dozens of times when I've tinkered. It's just a simple counter. It has one number, and you can add a number to it or subtract a number from it. But it's a really helpful demo app because it demonstrates two things: state and changes to state. And you can author it inside of a single Angular component. So this is how I've built my example app. I have two buttons that push values into a subject, either a negative one or a positive one, depending on which button you've pressed. And then I'm going to take that stream of values, and I'm going to use the scan operator to add that value to my starting number. So if I add a 1, it'll increment. If I add a negative 1, it'll decrement. Now I need to actually get this application working with Ivy and without zones. So how do I turn on Ivy? How do I get to Ivy? Well, it couldn't be easier than ever. All I need to do is run the ngupdate command, passing in the next tag for both Angular Core and Angular CLI. This will update me to the early versions of Angular 9, where Ivy is turned on by default. And that's all I have to do. But to turn off zones, I have to do a few more things. First, I need to go into my polyfills file, and I need to find the line where I'm actually importing Zone.js, and I need to comment it out. Then I need to go to my main.ts file, where I'm bootstrapping my application, and I need to let Angular know that I'm not actually going to be using zones in this application. Once I've done that, we can see the application has booted up, but when the user interacts with it, nothing is happening. Well, this makes sense. Since we haven't included zones anymore, there's nothing telling Angular when to run change detection. So that brings us to the first bit of Ivy API that we're going to use. We're going to use new change detection APIs that come with Ivy to try and trigger this. So traditionally, if we wanted to run change detection manually in our Angular applications, we would inject something called the change detector ref, and then we would call detect changes on it. And there are a few downsides to this. First, we had to actually inject it into the component that wanted to use it, which means that if we wanted to build functions or libraries to run change detection for us, the component would have to inject it itself and pass it to the library. It also had the downside where it might potentially cause change detection to run multiple times synchronously within the same frame, yielding maybe a performance hit. In Ivy, it gets a lot simpler. There's a function called MarkDirty where you pass it an instance of a component to run change detection on it. I don't need to inject anything into the component, and it's got some pretty interesting properties underneath the hood. To play with it, we can actually just open up the console in our Chrome developer tools and get at the component instance. From there, I can call some method on that component instance to cause state to change, and then I can use the ng probe to mark that component instance as dirty, which will cause change detection to run. But if we're going to build our library on top of this, we need to sort of understand what it's doing underneath the hood so that we avoid any potential gotchas. So what does MarkDirty really do? How does this work in an Ivy application? Well, the function signature is pretty simple. We're just going to pass in an instance of the component. Then Angular is going to do something called, it's going to get that component view for that instance. Now this component view data has enough information in it for Angular to go ahead and mark that view as dirty, meaning that when change detection runs, this component will now be checked and its bindings will be updated. Mark view dirty returns to us something called the root view. Now, we saw earlier that change detection runs on a tree of components. Root view is really just pointing to the top of that tree element. From there, MarkDirty is going to do something called schedule tick, and it's going to pass in a root context and a flag to run. So what is root context? Well, root context has information about how our Angular application is meant to run. And for change detection, there's two parts of it that we want to pay attention to. The first is a scheduler function. The scheduler is going to be responsible for making sure that some amount of work happens after everyone has scheduled work to be done. The second is the flags. Flags tells the root context what work will be done when the scheduler fires. So if we go back to our schedule tick, we can start to unpack what this is doing a little bit. By passing in the root context and a root context flag, it is instructing Angular that, hey, you need to do some work at some point in the future, and the work you need to do specifically is you need to detect changes on the Angular application. And this means that this function can be called safely multiple times without causing change detection to run multiple times. So now that we know how to use it, we can start using it inside of our components. So if we go to our component definition, first we need to actually import MarkDirty. And this is where I've got some bad news for you. MarkDirty, even in Angular 9, is not a stable API. So it's got a theta prefix indicating to us that we shouldn't build production software on top of it. But for this demo, we can start to play with it a little bit by using the import as syntax. Then I can use the tap operator to call MarkDirty on the instance of my component. This will cause change detection to run on this app component. Now if I run my app, things are working. I've got Ivy, and I don't have Zone.js, and yet my application is updating live. But I don't want to call MarkDirty myself. I know that if I ask my team to remember to call MarkDirty, including myself, we're all going to forget to do it sometimes. So I want some other piece of code to be responsible for calling this for me. And that's where higher order components come in. Now here's something interesting about them. I don't actually know how, as a community, we're going to build higher order components yet. It's so early, this idea of bringing higher order components into Angular, that it could be built with inheritance, decorators, or functions. I'm not sure, and I'm really curious to see how this shakes out. For this demo, though, we'll build them with inheritance. And the idea is that we're going to modify the behavior of our components, change something about the way they run or render or how change detection works. And what's great about them is they can call new Ivy APIs like MarkDirty on our behalf. So if we go back to my API design, where I had this connect hook, I could actually build this using a higher order component. So what I'm going to do is I'm going to create a class called reactive component that everyone will extend if they want to get this behavior. When you extend it, you get access to a member method called connect that you can pass in that dictionary of observables to, and will cause state to update live. So this is how our API is actually going to work in an Angular app, but how do we actually build this? That doesn't seem particularly clear how we'd go build this connect method. So aspiring open source library author, let me tell you, if you're going to publish an open source library for Angular and you don't get the types right, you will have nothing but issues for years. It turns out Angular developers really like it when our libraries are well typed and they don't have to work around the type definitions that come with your library. So if we want to get the types right, we need to leverage Inference. And here we can see this is what the user is going to provide to us. They're going to provide us an interface that matches something like this. And we need to be able to infer, using a special type, the result that looks like this. And to do that, we can use a type alias. Here I've created one called Observable Dictionary, and it's going to be using TypeScript's mapped types feature to actually do this inference for us. So this will be a kind of complex type, so let's break it down piece by piece. If we start with the following state definition, we're going to first use the key of operator to get every key in that input type. Then we're going to iterate over each of these property names to map into a new object type. From there, we could index the original type to get that original value. So now we've rebuilt that original value up. And now we can nest it inside the generic parameter of the observable type, allowing us to get from that original type to the inferred one for the observable dictionary. So that gets us our types all in place. Everything will infer correctly. Now we need to actually implement this connect method. So we'll start by creating what I'm going to call a sink. As we subscribe to values, we're going to dump them inside of this sink. And to get at those values, first we have to enumerate over all of the keys inside of the dictionary. I'm going to build an observable from these keys, and then I'm going to take every one of these keys, and I'm going to look up that original observable that the user passed in. When that observable updates, I'm going to write that new value to my sink. To get this all running, I'm going to subscribe to this observable that I've built up, and when any value changes, I'm going to go ahead and call MarkDirty, which will run change detection on my Angular component. It looks a little complex, so let's break it down what it's really doing. Let's say you pass in a dictionary that looks like this, where I've got an observable of vegetables. What this will do is it's going to subscribe to that observable, and whenever a value changes, it's going to update that value inside of my sink, allowing me to use that value directly in my template. So now that we have an implementation, we can go back to our component, and we can now go ahead and remove the import to MarkDirty, and instead extend our new higher order component. Now that we're extending reactive component, we have access to these state values, and the subscriptions are being managed for us. So we can go back to our template now, we can rip out the async pipe, and we can just use state.count directly. Everything's looking really great. But I go run the application, and something's broken. What's gone wrong? So I open up my console, and I've got this really long error. And it's something like cannot read property node index of undefined, and I don't really know what that means. But when I look at the second line, I see something familiar. Get component view by instance. Well, hey, I remember when we were calling that in MarkDirty. Angular calls this as part of us trying to run change detection. So what is this really doing? Well, the way Ivy kind of works at a very, very high level is it's going to first instantiate an instance of our component, then it's going to create our component view for us, and then it'll call the on-init lifecycle hook. So if we go look at the definition for that connect method again, the problem happens to be at this line. We're calling MarkDirty on the instance of our component before the component's actually been initialized. So we need to use lifecycle hooks in our higher order component. How do we do this? How can a higher order component get access to lifecycle hooks? Well, it turns out it's fairly straightforward. All we have to do is implement the lifecycle hook, and Angular will call it for us. But I don't want this in the format of a callback. I actually want to turn this into an observable so that I can compose this in my streams and offer observable lifecycle hooks to anyone using this higher order component. So I'm going to do that by initializing a subject, just a simple replay subject, and when ng-on-init gets called, I'm going to next a value into it, could be any value, and I'm going to mark the subject as complete to let any subscriber know that lifecycle hook has been called and won't be called again. But, library author, let me tell you that if you expose something like this, your users will break it. So we need to hide some of these implementation details. To do that, I'm going to hide some of these properties behind symbols. That way, consumers of this higher order component can't actually get at these properties other than the on-init observable. I'm going to do the same for ng-on-destroy. So now I've got observable forms of on-init and on-destroy, and I can go back to that update sync observable, and I can make some updates to it to make this actually work correctly. So what I'm going to do is I'm going to use the concat observable factory. And I'm going to pass in on-init first, and then update sync. This will ensure that on-init has actually run and has completed before I try to update my sync values. Then I'm going to use the take and tell operator on it, and I'm going to pass in the on-destroy lifecycle hook that I've created. This means that the subscription will be automatically cleaned up for me when this component is destroyed. Finally, I'm going to subscribe to this observable, and I'm going to mark the instance as dirty. So now if I run my application and I either hit either of the buttons, values are updating live. I've got change detection running for me automatically. I don't have to use the async pipe in my template. Subscriptions are guaranteed not to leak because the higher order component is managing those for me. And if I do something more complex, like I'm using subjects with a service, then I can leverage this higher order component to connect to that state management offering. Or if I'm using NgRx, I can take those observables that NgRx is giving me, and I can use the connect method on those too. And in fact, libraries like NgRx and NgXS and Akita could take this idea one step further, and they could offer their own higher order components that remove a ton of boilerplate that we have to write when connecting up our components to state management solutions. So now that we've built reactive component, we've achieved a lot of goals we set out to do. Developers that use reactive component can use values directly in the view without the async pipe. It's easier than ever to not leak memory accidentally because we're no longer responsible for managing subscriptions. And this makes it possible for us to build entire Angular applications without zones by leveraging the idea that all of us use observables to track state changes. So maybe you're wondering, how can I use reactive component? Can I run out and use it now? And the answer is, unfortunately, no, because like I said at the beginning, I need your help to build this. I'm really excited to announce a new initiative on the NgRx team called NgRx Component. It's a library coming directly from the NgRx team to make building reactive components easier than ever. It's very early days, but our idea is to build this on top of some of the new APIs that are coming out with Ivy. And we want you to get involved to help us make this library really fantastic. To jumpstart you, here's a link to the slides, along with all the code demos that I've showed in this deck. You can actually run this application live and start playing with this idea now. Thank you.